So this part is about the WISE GUI, WISE GUI, however you want to call it. The WISE GUI is a web-based frontend, as Alex was already saying. It's basically available on all the Santander deployments, SmartSantander deployments, so in Santander, Lübeck, Patras, and Guildford. And it has been also inherited by the WISEBet project initially. So what is really nice about the WISE GUI is that it's web-based, meaning basically that you don't have to install anything, you don't have to be, well, familiar with any of the tools or the terminology or the APIs, so you can just like browse to the website and try it for yourself how to experiment with the testbed. So for most of the people starting to interact with the testbed, that will be the first stop to go to. Well, here is a URL for the Lübeck deployment. As the Wi-Fi is really bad today, like my laptop keeps getting connectivity and then losing it again, I will use my local testbed. I've just set up a local testbed here, so it will look a little bit different. I will only have 2 nodes attached to the testbed, but I think it should basically work the same. As Alex was already saying, that this tool is mostly about systems level or node level experimentation. His tool, the Timon, covers also resource selection. In the WISE GUI, the resource selection is more done by hand. You have a table to select the nodes. So assuming that in case you do some systems level experimentation this week due to the assignment or out of interest, and you run into any issues, please just come to me, because I will be here all week. I might not be in every session that you are in, but I can probably help you if you run into any issues. Or also, if you want to provide me with feedback, I would be very happy to get that feedback. So, one last thing before I start running through the user interface is that all these projects, naming the testbed runtime, which is the very basis of the infrastructure, also the WISE GUI and the experimentation scripts that I will present afterwards, they are all open source and they are all available on GitHub. So, well, you're also welcome to contribute, obviously, but if you run into any trouble, you can just look up the source code, the documentation, which is also there. Contact me, post on the mailing list, whatever. Any channel might help to get going. So, excuse me, I will sit down because this is slightly easier to present a user interface. So now what you see is the graphical user interface of the WISE GUI. As I said, it's a local testbed. I have quickly set it up due to the Wi-Fi issues. So you will be presented with such a screen at the beginning. You select the testbed, so WISE GUI can support multiple testbeds. And usually here in this overview view, you would be presented with a Google Maps based view, which is currently not loading due to the Wi-Fi. Where you could also click on the individual nodes, see their capabilities, or if you click on the tabs of the nodes, you will see a table with the properties of the testbed nodes. So usually there will be some position information, the sensors that they have. So you can see right now that there are several nodes inside the testbed. Some of them are currently attached. It's these 2, obviously. So I have some more here. And now if that table is a little bit bigger, obviously, if you have 290 nodes, as is in the Lübeck testbed, you can just use that select box here. And there are more node types to filter between node types. Or you can type any expressions for example, if you would want to have every node that starts with that suffix, in this case only one. But you can basically type a lot of expressions to select the nodes. You can remember that expressions for your experimentation. So then, next step would be to log into the testbed. For the Lübeck deployment, you could just follow this link to register and get an account. In this local testbed case, I have configured it to just accept anything, which is very convenient for now. But there is documentation that you can follow on how to sign up and then how to log in into the testbed. As soon as you have logged in, there will be two new fields, one being the currently active reservations that you have made. As we didn't make any reservations yet, there are none. And there is also a make reservation button on which we are now going to click.
There is maximum number of nodes that we can select or something?
Sorry?
There is maximum number of nodes that we can select or something? I mean, if we have 7 teams and in parallel we are selecting, I don't know, 50 nodes.
Yeah, we would have to kind of synchronize and basically. Well, from the software side and the architecture, there's no kind of limit to either time or nodes.
No, I mean just over here this week. I mean,
this week, I think we should just get together for those who are interested and synchronize with each other so that we don't overlap. I've also printed out some papers with all the sensor nodes, for example in Lübeck, so we can just take a scissor, cut that into pieces and give it to the individual groups. Okay. So basically what you do is you select the reservation time span. Default is something like an hour. You can have some description for you to remember what reservation that should be. And then you select the sensor nodes that you want to have for your experiment. Click on reserve. And the reservation seems to be done. And now we find that reservation appear in the current active reservations drop down. Okay. As soon as you kind of connect to this reservation, you will be presented with this live data view. Which basically will present you with all the sensor node outputs that are being generated, meaning like whenever a sensor node will print something to its serial port, to its UART, it will be forwarded towards this browser window that you have. So obviously I have programmed them with an image that does not put out a lot, so I can use the controls down here to, for example, flash the nodes, reset the nodes, send a message to nodes, or even script something. I will talk more about that later. For now, I can reset the nodes by selecting them and pressing reset. And as you can see now from both nodes, we get some output. Basically, the first column of that kind of table is the timestamp. This timestamp is taken on the gateway host to which the sensor node is attached. In this case, it's obviously my laptop. In a real deployment, it would be the gateway host, namely one of the Guru plugs in the Guildford deployment, some of the gateway devices in Santander, or in Lübeck testbed would be some network. So this timestamp is what Alex was talking about, very important for synchronization issues. It will be probably NTP synchronized. It's not perfect, but pretty perfect. Then the second column denotes the so-called node URN, so the uniform resource name. And the suffix is what corresponds to the MAC address of the sensor node on the 802.15.4 channel. And the third column of the output is the actual bytes that have been written to the node serial port. In this case, the user interface interprets these bytes as an ASCII string, so kind of human readable. And as you can, if you know the ASCII table, not every character, not every byte has an ASCII representation. That's why, for example, you can see here the byte 0 is printed as a null character, but still the output is human readable, which is very convenient. If you need access to the raw data of the sensor node, you have, for example, here this this modifier to switch the output. You can basically switch, for example, to a hexadecimal printing. So this will be presented as hex values, or switch to decimal or binary representation. Oh, sorry. There are several more options. You can switch on and switch off columns. You can filter by node. For example, if you have 200 nodes, it may result in your browser crashing, kind of, because JavaScript is not the most efficient way of implementing stuff, but it's a very convenient one. So it might be a good idea sometimes to just filter out kind of browser grep for the nodes that you are interested in, and then we would only get output of the individual nodes. So if I now have the filter on and I reset both nodes, I will only get the filtered view. So what else can we do? We can flash, reprogram the nodes. For this we can go to the corresponding control, select the nodes that we want to flash with a particular image. In this case I will only select one node, select the image to be flashed onto the node, some precompiled images, and then I could just start flashing it by pressing the flash button. Or what I can also do, if I have several sets of nodes for my experiment, one running one image and another node running another image, I can also click on that plus button to create several sets of flash configurations, which then will be distributed onto the selected nodes. So let's just take the second node on the second set, flash it with a different image, test, and I can also load and save these configurations for later use, and then I can just click on the flash button, and you'll see down here there is a new alert. So let's just take a look at it, some older alerts, and there is a progress bar indicating the flashing progress. So, okay, obviously it worked. And now if we choose not to filter anymore, we should see some other output from the second node that we flashed with a different image. Anyways. Okay, if you need to send commands to the sensor node, you can do that with the send message functionality here. Basically, again, you select the nodes that you want to send the commands to, and you can choose between having the input as binary data or ASCII data. ASCII basically meaning you can type whatever you want on your keyboard. Binary meaning you have to follow a certain message format, but you are free to mix, for example, hex values and binary values. And you would distinguish individual bytes with commas. So I can send this message now, and in case the node would understand what I want from it, so interpret it for example, as a kind of RPC command. You could, let's say, for example, send a start command, start with the experimentation now because everything is set up. Or let's say you could send some commands indicating to use a different type, a different set of parameters for algorithms that you implemented on the node or whatever. So that's most basically all the functionality that is provided, but I also want to present you the small utility that's also built inside the WiseGUI. That's the scripting editor. I will not do it as a live presentation, but switch back to the slides. There it is. Okay, just for you. All the slides will also be available for you to download, and I have all these nice screenshots of the user interface for you to look at again. And okay, here we are talking about the scripting environment. So the idea is that sometimes it's very convenient to just script your experiment to your custom use case, and in that situation you can either go and implement your own client solution to, against the APIs of the testbed, or you could just use this very convenient scripting environment which is included in the WiseGUI. What you do inside this GUI, you have a small editor which looks like that, and you basically implement your code against the REST API that we've also integrated. And even more convenient, you can just use the wisebed.js client library, which is part of this WiseGUI project. So you have some very basic functions like flash the node, send a message, and so on. The scripting environment, and that's a very convenient thing, is pre-initialized with a WebSocket connection that's basically kind of directly connected to the node serial port. So whatever you will send over that WebSocket connection following a certain JSON message format will be forwarded to the sensor node serial port and then can be interpreted by the sensor node. So that's basically what you can also do. The scripting environment is basically the same as the thing you can do with the graphical user interface. And also you have some metadata about the reservation that is currently going on available as JavaScript objects to interact with. If you write that kind of script, you will basically have to follow that skeleton, which is available to you as soon as you go to the website. You have some lifecycle hook methods, the start method, and there's also a stop method. And as soon as you're done typing your script, you can just press the start button and the execution of the script will begin. And you can start to interact with it. Just to give you a quick impression, what we also did is not only to automate experiments, but also we had some issues some time ago with I think it was last year in the Google Summer of Code project for one implementation of the constrained application protocol CoAP. We had some issues with the IPv6 layer, we had some weird routing issues, and we wanted to find out if that weird routing table that we observed really actually is true. So we just sat down for something like an afternoon and tried to implement a visualization using that scripting editor. And in that application, the sensor nodes periodically sent a ping, IPv6 ping, to other nodes in the testbeds. Then we instrumented the nodes to dump these received packets to the serial port, which is then forwarded to the scripting environment. Also, in order to distinguish several concurrent transmissions of pings, we inserted some kind of label so we can distinguish them. And the target was a live, so basically real-time visualization of the packet trajectory in the wireless network. We use some client libraries, the usual stuff. In case you don't know it, D3.js is a very nice and convenient library to work with any kind of data. And what you will see is that kind of output. So use the scripting editor here. And once you start a JavaScript application, it has the full mightiness, the full feature of JavaScript in a browser. So basically meaning you can manipulate the document object model of the browser, you can do all kinds of manipulation. In this case, we inserted some visualization graphics, and what you see here is basically this node sending a ping to this node, and following the arrows, you can see that it in fact had a really weird route. And just to give you an impression, I have this small video. Let me just screencast. So I think we just flash the application that does the pinging. Here we have the script that we paste into the scripting environment, which is something like 350 lines long, so not really big. Copy and paste it into the scripting environment. Obviously, not in a hurry. I think when we recorded this screencast, the CPU was really heavy loaded with recording the screencast and compressing it while we are recording it, so everything was a little bit chilled. Okay, then we start the script. You should see immediately the output. Okay. Now there should be periodic pings. And you can not only see that the routing table seems to be kind of weird, but also not every time the ping arrives at the goal, like now, for example, that one ping went to its final destination, the other does not, and the next time it does. So obviously due to interference we can see this type of issues. Okay, so if you have any questions so far about the Wise GUI, that would be the perfect time.
Just a photo.
It's always fun with this Microsoft product on a Mac. Let me just... It's not really working well with the full screen mode sometimes. Okay, here we are back. So, the second part that I want to present is basically the called experimentation scripts. We've been hearing that testbed runtime and the testbed infrastructure is a kind of a legacy application inherited from WiseBed. So also these experimentation scripts are inherited. They were initially written by Dennis Pfisterer, who was also talking last year, and me together. So that was kind of the first experimentation tools that were ever developed for the WiseBed APIs. And it's basically it has been used by lots of people and allows you some basic stuff, the same basic stuff that we've seen right now. Basic operations such as flash reset. You can script your own stuff basically by extending the scripts. So the scripts is a collection of of basic operations like flashing and resetting and sending messages and stuff. But also they usually serve as a starting point for your own implementation. So whenever you want to, let's say, automatically repeat your experiment, or in another way automate your experiment, you could go to the experimentation scripts, download it. As I said, it's open source. Look at the implementation, see how the API is used, because usually the best documentation is implementation. Well, there is API documentation, but nothing documents an API better than the code that's actually using it. So you can go to the web page, you can go to the documentation, which is pretty full, pretty long. I just want to run you through the basic setup of the scripts. The scripts are a collection of bash scripts, so there is unfortunately no equivalent for Windows users. There is no batch files, but as it's all based on Java, you can simply just look at the bash scripts, copy them to batch files, and then execute it on Windows. That's not a problem. But these bash scripts, what they basically do is to invoke the scripting client execution environment, which is a Java application. The environment itself boots up with a so-called Bimschas interpreter. Bimschas is a, let's say, 97% Java type of programming language. It's a kind of simplified Java. It allows you to do some less strict implementation stuff, and it allows you to be interpreted at runtime. So what it does, if you invoke one script, it will finally invoke the interpreter with a script written in Bimschas Java, and this script can then access to some pre-initialized environment with the SOAP API, client library, and several helper classes. So all these kinds of stuff, you can follow also here the links down here to the individual projects, the environment itself, how it's pre-populated with stuff, the API of the WiseBed or SmartSantander API, and also how this API looks in Java. So now should also follow a live presentation, but I will just quickly run with you through the screenshots. I think they will give you the idea. What I will do is also, I will just first list the node URNs, filter them for the type of iSense, I will reserve them, check if they're alive, flash them, listen to node outputs, and finally reset. So how it looks, what you need to get started is first to have a properties file, just configuring some addresses on where to connect. It's not important what these individual properties now mean. You can just look at the documentation later on, just for you to know that you need this kind of property file. By the way, is this okay to read, or? Okay. In this case, I will just try to make it more readable. Okay.
We need to learn the addresses by heart.
Sure. Always.
No lunch.
No.
No lunch. Are we running out of time, or okay?
Yeah, overall, maybe 5 more minutes.
5 more minutes, okay. So for every of these scripts, it's basically the same. First, you set the command, like in this case, WB. All commands are prefixed with WB. WB lists node URNs. Then you pass the properties file. In this case, it's in some environment variable. And whatever arguments the script will ask for. Just look it up in the documentation what arguments the script allows. So then what you would do next typically is to reserve the nodes by calling the WB reserve script, passing the properties file again, duration and offset starting from now, you pass a 0, and the sets of nodes that you want to reserve. In this case, I had exported them to an environment variable before. What you get back is some kind of so-called secret reservation key. We'll also memorize that in an environment variable to use them afterwards. And then basically all the subsequent steps that need a reservation, you will always, again, call the script, pass the properties file, pass the reservation key, and then you will get some kind of output. In this case, true for node is alive, false if it's not, and the corresponding node URL. It also works for printing out the sensor node outputs, so that's the WB listen script. Again, you will be presented with an ASCII interpretation of the output and hex value interpretation. So this is basically the same what you saw in the voice GUI now as a shell script. And it will equally work for resetting the nodes, flashing the nodes, and that's how these scripts work. And as I said, wherever you need to do something with the test bed which is more advanced than these basic operations, you can just download these scripts or just browse their source code in the browser on GitHub, and then you can start to modify them and use them for your own purposes. So this will be it.